Welcome friends. The purpose of this presentation is to take you through the basics of phacoemulsification. By the end of this presentation, which I would say part 1 of a series of presentations, you should be able to understand what are the different palm systems in phaco, the foot pedal signs, how to use the foot pedal, and you would also have an understanding on the Phaco Fluidics. So let's start the part 1 of this presentation today. So friends, what is the purpose of phaco? Why did we move from ECC to SICS to phaco? The very objective of phacoemulsification is to give a faster and a better visual recovery to the patient, so that the patient can go back to his work quicker. Hence, we go from a very big incision size, what happened to be during the days of ECC, to today's 2.8 millimeter incisions, or even lower than that, 2.4 or 2.2 millimeter incisions. The very basic idea beyond this is to give a faster visual recovery to the patients. However, this criteria will not be met. We will not be able to give the patient a faster visual recovery if 3 basic criteria are not met by the phaco machine. These 3 basic criteria are: 1. In phacoemulsification, inflow has to be always equal to outflow. If your outflow from the eye is more than the inflow, then there's a chance of chamber collapsing, just like the balloon that you are seeing in the picture. You do not want to be in a situation like that. So you want the eye to be firm enough for you to do the phacoemulsification. Hence, in phaco, the basic rule or principle is that your inflow should be always equal to outflow. The second principle of phacoemulsification is that minimal turbulence. Whether you are in the aeroplane or you are doing a phaco in the eye, you do not want turbulence. That's not something which is desirable. What happens when you have turbulence inside the eye? There's a lot of fluidic turbulence. Your phaco, your nucleus pieces go here and there. And then they might go and rub against the corneal endothelium, which is not a very happy situation for the doctor. So the second principle of phaco is that whichever machine a doctor demos, it needs to give a very stable environment in the eye, less turbulence, minimal turbulence. A third important principle of phaco, which has to be met by any phaco machine, is that it should be very gentle on the incision. It should be very gentle on the cornea. It should not, the ultrasonic vibration of the tip should not lead to a heat buildup or a thermal energy buildup on the incision site, because that will lead to the wound burn. That is, it will lead to the damage of the endothelial cells. And we all know that the endothelial cells are single layer of cells, and this will not regrow. So it is very important that the vibration of the tip does not cause a buildup of heat on the incision site. So the 3 basic principles of phacoemulsification are, again I repeat, inflow should be always equal to outflow. If the outflow is more than the inflow, then the eye becomes what you see in the picture, like the balloon. Second principle is less turbulence in the eye, right? very stable chamber in the eye. And the third is less heat buildup at the incision site. If you have a lot of heat buildup, it leads to wound gaping, and it will lead to postoperative complications like wound leakage, which can lead to infections. All right, now let us understand the peristaltic pump, how it draws fluid from the eye, and also related to the foot pedal signs. So what you see in figure 1 is the peristaltic pump. The peristaltic pump, actually the word peristaltic comes from the word peristaltis, which means something which actually squeezes, contracts, and releases. Squeezes, contracts, and releases. So something like, to some extent, how a snake actually has its foot. So what the snake does, it contracts, squeezes, and releases. And that is how the snake actually has its food. To some extent, it is also what happens in a peristaltic pump here. As you can see in this video, the pump is rotating, and as it rotates, the hub roller rotates. In this picture you can see three pinch rollers. So these three pinch rollers are also now rotating. As it rotates, it will pinch the tubing that goes over it. It pinches, squeezes, and releases. So these three rollers now are in continuous action. They are attached to the tubing, and because of this action, the fluid is getting drawn. Where it is getting drawn from? It is getting drawn from the eye. You have a phaco handpiece, and you have the tip that goes into the eye. So it draws the fluid from the tip. Now the question is, where, when does it draw the fluid from the eye? How is it related to the foot pedal? And if it is drawing fluid from the eye, how is the fluid getting replaced in the eye? And to understand this, you have to see the picture 2. So what happens in a phacoemulsification machine is that the fluid is drawn from the eye, and what we call it as an aspiration. As it aspirates, fluid is also drawn into the eye now, which we call it as irrigation. So fluid moving out of the eye is aspiration. Fluid moving into the eye from the bottle that is hanging in picture 2, you can see attached to the machine. So from the bottle there, the BSS or the water is now going inside the eye. And this is because of the gravity, because it is hanging and it has a pressure, it has a gravity pressure. So as fluid moves out of the eye, because of the pump rotating, we call it aspiration, it is also getting filled because the fluid now will come from the bottle. The eye is a closed chamber. So if you have the fluid going out of the eye, you will also have it replaced because it is attached to a bottle with the fluid. Now, let us relate it to the foot pedal science. So in a foot pedal, there are 4 positions. In foot switch position 0, there is no action. And usually, if you take the span as 100%, from 0 to 5% is the foot switch position 0. And at that point of time, if the surgeon is within that span from 0 to 5%, there will be nothing. He will not get anything. As he presses foot switch position 1, what happens is that the solenoid opens up, the pinch valve opens up, and there will be irrigation pressure into the eye. Where will the irrigation come from? The pressure come from? From the bottle. in gravity fluidics. However, note, during this time there will be no flow, because if you press a bottle full of water in your hand, a plastic bottle full of water in your hand, as long as you have not removed the cork or the cap, you will not have any, you will have, you have a pressure on the bottle, but you will not have any fluid coming out of it because the tap is there, cap is there. However, as you rotate the cap and loosen it, fluid will start coming out, and that is exactly what happens in Futz's position 2. Now in Futz's position 2, the pump starts rotating and it is drawing fluid from the eye. Therefore, there will be also irrigation. Because aspiration is there, irrigation will also start because it's a closed chamber, and BSS or water will start coming from the bottle. With what pressure will it come? Will depend upon the bottle height and also the rotation of the pump. In Futz's position 3, now you have Phaco power also together with irrigation and aspiration, because you need to now break the nucleus pieces into smaller pieces so that you can take those nucleus pieces away from with the help of the handpiece. It goes through the handpiece, goes through the tube handpiece, and then through the tubing and into the drainage bag. So that's basically foot pedal science. Irrigation in foot suspension 1, in foot suspension 2, irrigation plus aspiration, and then in foot suspension 3, you get irrigation, aspiration, and Phaco. Notice that the Phaco does not come, that is, the ultrasonic power does not come in foot suspension 2. It only comes in foot suspension 3. So this is basically the foot pedal science and how it is related to the peristaltic pump. So to aspirate the things from the eye, the cataract from the eye, you need 4 things and what we know as Phaco Fluidics. You need irrigation, you need aspiration, you need the buildup of vacuum, whether it's a Venturi pump or a peristaltic pump, you need vacuum. The only difference is how it builds vacuum. It is different between the two pumps. In peristaltic pump, you only build vacuum when you have the Phaco tip occluded. You can see the Phaco tip over here. When it gets occluded by the nucleus space, it generates vacuum. You will only get vacuum in peristaltic pump when the Phaco tip is occluded and when you are in foot suspension 2. So as the surgeon goes from foot suspension 0 to 1, there's irrigation pressure in the eye. However, there's no flow till then. When the surgeon goes to foot suspension 2, the fluid now is drawn away from the eye because the pump is rotating. Pump is drawing fluid from the eye. And as the pump draws fluid from the eye, the small nucleus pieces starts coming towards the Phaco tip. Once it comes to the Phaco tip, it occludes the Phaco tip. Here occlusion means, in simple language, it blocks the Phaco tip. At that point of time, when it blocks the Phaco tip full, there will be no flow because you have blocked the Phaco tip. It will have no place to draw fluid then. At that point of time, does the pump stop rotating? No, the pump doesn't stop rotating. The pump goes on rotating because it has to generate the vacuum. How much will the pump generate vacuum? That depends upon, well, you may have set a vacuum, preset vacuum of 400. Your machine is capable of generating 500, up to 500 vacuum or 600 vacuum. But you, for safety, you have kept a preset vacuum of 400. That means you're asking the machine to generate a vacuum in a peristaltic pump. Remember, vacuum is only generated when the occlusion happens. That is, the tip is blocked by the phaco piece. There's no flow. Pump is still rotating. When there's no flow, what happens inside the tubing? It has to generate vacuum then, because you have got rid of the fluid in the tubing, which is attached to the phaco tip. So when the pump draws the fluid and it gets rid of the fluid, whatever residual fluid is there in the tubing, it has to generate a vacuum because you have occluded the tip, yet the pump is rotating. So the vacuum will be generated inside the phaco tip, inside the tubing, till the cassette level. How long, how much will the vacuum generate here? Till your preset vacuum. So in this case, you have kept a preset vacuum of 400. So the pump will keep on rotating as long as the vacuum is not generated till 400. As the vacuum is generated till 400, you will find an occlusion tone. So in a phaco machine, you get that occlusion tone, beep, 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 beep. Different machines have different tones. But you know with that tone that you have generated the preset vacuum, you have got a good hold of the nucleus piece. Why do you need that vacuum? Because you need to have a good hold of the nucleus piece. And why do you need to have a good hold of the nucleus piece? Because you will now hit the nucleus piece with power as you go to foot suspension 3. As you go to foot suspension 3, you get power. So the nucleus piece now will be hit and it will break. As it breaks, the occlusion is lost. The phaco tip is not blocked now. The nucleus piece, which was so long blocking the tip, is broken. And more fluid is now drawn from the eye because the pump starts rotating again. As the pump starts rotating again, those nucleus pieces which have been hit and which have cracked and which have become smaller, they will be drawn through the phaco tip and got rid from the eye. So that's actually the process of phacoemulsification. You need to have the vacuum generated, and in a peristaltic pump, you can only generate vacuum when there is a block of the tip, that is occlusion. As the occlusion is happening, yet the pump is rotating, there's no flow, vacuum is generated inside the tip, inside the phaco tubing. As vacuum generates, you get a good hold of that nucleus piece on the tip. As you get a good hold, now you go down to foot suspension 3, and in foot suspension 3, you get the ultrasound power to hit the nucleus, break it into pieces. As you break it into pieces, what happens is that the vacuum drops, the pump starts rotating again. As the pump starts rotating, the nucleus pieces that has been broken is got rid, and it is now sucked inside the phaco tip and thrown into the cassette and into the drainage bag. So that's basically the science behind phaco machines, the peristaltic phaco machine. So in this slide, what you see is that the nucleus piece has got blocked, is blocking the phaco port. And in the world of phacoemulsification, we call it occlusion. As it occludes, the pump is still rotating, right? You can see at the far down at the right side, the pump will still rotate in the picture over here in the green color. The pump will still rotate, but the phaco tip is blocked, so there's no fluid now. What happens is that between this phaco tip and the pump, in this tubing and in this tip, you generate the vacuum. As you generate the vacuum, there will be no flow, but the pump will go on rotating. Vacuum will be generated till the preset level what you have set in the vacuum. In this case, it is 195. You can see the vacuum has been set to 195. At the far left corner, you can see the vacuum has been set to 195. Once you have set it to 125, the pump will rotate and it will stop only when the preset vacuum reaches 195. As you have got your preset vacuum, the occlusion tone comes, and then you use the phaco power. You go down to foot switch position 3 and use the phaco power. So friends, that was in brief about the science of fluidics, phaco fluidics. We talked about how vacuum is generated in a phaco machine and in a peristaltic machine, what is the role of the flow rate, irrigation, flow rate, foot pedal science. In the next part, we will talk more about the ultrasonic power. What are the components of ultrasonic power? When we say power is delivered into the eye in foot switch position 3, what exactly we mean by that? For more informations, you can log on to my Facebook page, Shubho's Ophthalmic page, or you can also follow my website, quickguideshubho.com. We'll come back more on basics of phacoemulsification. Till then, goodbye.